So now things are going to get a little more complicated. Did you really think that part per million and part per billion would stay that easy? And the answer is no, of course not, right? So now we need to touch base and we need to go one more step further. So in the previous video, we talked about making a part per million solution. Well, if this will work for me, let's try this again. And the assumption was that we wanted to make a part per million of the entire compound that I'm dissolving. So I'm going to put compound here, or I'm going to put some kind of solute. And sometimes that's not the thing. That's not what we're after, right? So sometimes in regards to the entire molecule itself, part per million and part per billion, previously, that's how we would calculate it. Very simple calculation. You put what your concentration that you need over 1. That's equal to how many milligrams should you weigh out divided by how many liters you're trying to make. Cross multiply and divide. Simple as that. No more to it. However, sometimes in a laboratory, we're not interested in the entire compound, and we're not interested in the entire solute, if that's what we're given. So let me give you an example. Let's say that I bring in sodium chloride to the laboratory. Well, what if I wanted to make 100 part per million solution of salt as a whole? Well, I could do that, right? And I would do that like we did before. I want to make 100 ppm over 1, because ppm means milligram per liter. And let's say that I want to make 50 mils of the stuff. So 0.050 goes there. Cross multiply and divide. That's what all of those examples were last time. But there is an instance where I might not want to make 100 ppm of the entire thing. What if I wanted to make 100 ppm of just sodium? Or what if I wanted to make 100 ppm of just chlorine? I can do that. 100 ppm sodium solution, or 100 ppm chloride solution. How do I handle these types of problems? And these are the ones that are a little more complicated, and these are the ones that make people the most confused. So let's talk about how to do it. Now, I want you to keep in mind that if you did 100 ppm salt and you took 100, let me bring up the calculator just so that you can follow me. You cross multiplied and you divided. So 100 times 0.050, that gives you 5. Okay? So we've got 5 milligrams of NaCl to dissolve. If you wanted to make 100 ppm of sodium chloride and you only need 50 mils, you should weigh out 5 milligrams of the salt. Well, if I weighed 5 milligrams of the salt, this weight represents the entire salt structure. It represents NaCl's weight and chlorine's weight. So if I weigh out 5 milligrams, that will make me a 5 ppm solution, or 100 ppm solution, based on this example. But it would not make me the 100 ppm solution of sodium. Or it would not make me a 100 ppm solution of chlorine, because that salt weight incorporates both, not just one. So theory-wise, I should always weigh out more, right? If I want 100 part per million sodium, and I understand that some of that weight is coming from the chlorine that's involved in that structure as well, then I'm probably going to have to weigh out a little bit more in order to make the 100 part per million of just sodium. Does that make sense? The same way with chlorine. If I needed 100 part per million chlorine, well, if I weighed out 5 milligrams of sodium chloride, I have to understand that that 5 milligrams, it's not all chlorine. That 5 milligrams is the sodium as well as the chlorine. So if I want a 100 ppm chlorine, I'm going to have to weigh out a little bit more, because I have to understand that some of that total weight is coming from the other species or ions that's involved in the salt structure. So how on earth do we do this? What's the best way, the easiest way to figure out how to make these PPM and PPB solutions if we're just interested in one of the ions and not the entire structure itself? Well, I'm going to show you how easy this could be. So to do this, you need formula weights. And we need the formula weight for sodium chloride. So we know that sodium's 22.99 based on the periodic chart. And we know that chlorine is 35.45 based on the periodic table. And then if we add both of these up, we're probably going to get somewhere of 58, 59. So 58.44 grams per mole. And that's the formula weight. So that's really where we need to start. So whatever type of compound that you're using, you want the formula weight for that compound first. And then we need to set up a ratio, right? We need to figure out how much more do we need to weigh out in order to negate that extra weight that either the sodium or the chlorine's coming in to bring me. So let's do the first one first, okay? The 100 ppm of sodium, and let's say that I need 50 mils of that solution. So what I would do is I need to, number one, I need to figure out what my multiplier is, my factor. And that's how I'm going to list this. Solve for the factor first. So because I'm looking at sodium here, the way that I do this is I take the formula weight for sodium chloride, 58.44. And then I'm going to divide that by sodium's weight, which is 22.99. Now, this is going to be the total weight for sodium. So, for instance, if there was a 2 here, I would multiply this by a 2, and then that would give me the weight for that particular sodium as a whole. I use the whole number, not just the formula weight from the table. Okay, just so happens that sodium here is present with 1, so 22.99 is what we'll use. So that's the first step that we need to do. We need to solve for the factor, and I'll take 58.44 and I'm going to divide that by 22.99, and I'm going to hit enter, and my factor is 2.5420. Let's round it off. So 2.5420. So there's my factor, and that's what we would call my multiplier that I'm going to be using in just a second. Okay. Now I want you to keep in mind the factor should always be greater than 1. And the reason is because the salt brings with it the weight of everything. Okay. And I just maybe am interested in one part of the salt structure, not the whole thing. So if I flip these two things around accidentally, that's basically going to tell me to weigh out less amount, which doesn't really make sense, right? If I go through and use that multiplier and solve for an answer, why would I need to use less amount of salt to make the concentration that I need if I'm trying to factor in the whole thing? That doesn't even make sense, right? So this number should always be greater than 1. You will always need to weigh out more than if you were just focused on the entire salt altogether. Okay? So there's my factor. And then the next thing is that I will take this multiplier and I will take a look at the concentration that I need, right? And here I need to make a 100 ppm. So what I would do is I would take my 100 ppm solution that I would need to make, and I would multiply that by the factor that I just solved for. And that's going to be 254.20 part per million. So that's really the target that I need to make with my salt. I'm going to be using sodium chloride, right? I can't use sodium by itself. There's no way for me to obtain that in a laboratory. And I can't just measure out chlorine minus by itself. I'm going to have to use some type of salt in order to get these. Well, what I've done is that I figured out a multiplier, a factor. I've taken that factor, multiplied it by the concentration that I need for sodium in this case. So if I'm using sodium chloride, which is what I've used over here, right? That represents the factor. That's why we brought it in. If that's the salt that I'm using, then I really need to be making a 254 ppm. When I make that, then that will have a 100 ppm sodium involved. But I need 254.2 ppm in order to do that. And then from that point, this is my target. That's my target concentration, and it turns into the same type of problem that you saw before in the previous video. So I only need to make 50 mils of it, right? So I need 254.20 milligrams per liter, and I need to figure out how many milligrams of salt to make 50 milliliters of that solution. So I'm going to take 254.20, and then I'm going to multiply, 254.20, and I'm going to multiply by 0.050, and then I hit enter, and I get 12.71. So 12.71 milligrams of sodium chloride that I would weigh out, dissolve in a volumetric flask, and that will give me 100 ppm of sodium, right? There's the difference. So it's telling me how much salt to weigh out in order to get the target amount of the ion that I'm interested in. All right, so let's do this again, but this time, hold on, let me get rid of some of this stuff. This time, we're not going to do sodium. So I'm just going to erase all of this. And now we're going to be focused on chlorine. So that means a new factor. Same formula weight, because let's say I'm still using sodium chloride to make it. But in this case, let's say that we are making 100 ppm, but let's say that we need 200 milliliters of this solution. All right. So I do the formula weight just like before. There's my sodium, there's my chlorine. I do the total formula weight, and then I need to set up my factor, right? I know that I only want a piece of the salt, not the whole thing. So I need to set the factor up, and I take the formula weight, 58.44, just like I did there. And this time I'm going to divide by chlorine's formula weight, 35.45. Again, that would be the total, so remember subscripts. And this will give me a factor, a multiplier that I would need to bring in. So 58.44 divided by 35.45. And I hit enter, and that gives me 1.6485. 1.6485. Again, keep in mind, this number should always be greater than 1 because it's always going to take more salt if you're focused on just one of the ions that you need. Okay? So now I need to make a 100 ppm solution. So I need 100 ppm of chlorine. So I'll bring in my multiplier of 1.6485, multiply those two things together, and in this case, I'll get 164.85 part per million. So if I want to make this 100 ppm chlorine, I actually need to make 164.85 ppm of salt in order to do that. Well, ratio and proportion now. 164.85 milligrams for every liter. How many milligrams would I need if I need to make 200 mils? So 200 mils is 0.2. So 164.85, and then I'm going to multiply by 0.2, and that's 32.97. So 32.97 milligrams of the salt that I need to weigh out, put into a 200 ml volumetric flask, and dissolve it. When I do that, this will give me a 100 part per million solution of chlorine. All right. So that's basically how we do pieces of a salt if we're only focused on one of the ions, either the cation or the anion. Now, I also want to kind of tie in here. What we're basing this off of is percentage. So 35.45. So 35.45 divided by 58.44. Let's just calculate the percentage that chlorine is contributing to the weight of the salt. So this is about 60.66%, right? I would multiply that number by 100. That would give me 60.66%. Now, I want you to watch this. So we have calculated using this factor that we need to make 164.85 part per million solution of sodium chloride. Well, if we made 164.85 ppm solution of the salt, what's the concentration of the chlorine? Well, if I take the percentage that chlorine contributes to the weight and I multiply that by 164.85 and I hit enter, I get a number that's really close to 100. That's why these are working out the way that they're doing, right? If I weighed out this amount of salt in total, well, I now know that around 60% of that weight is going to be contributed by chlorine. So if I take 60% of that number, I'm going to get, hopefully, my target concentration here in the very end, and that's 100. And that's what we're after, and that's what we want, okay? So I know that was a lot. And for that reason, we're going to do a second video, and I'm just going to basically do one example after another, change up the amounts on you just so that you can feel more comfortable with these types of problems. So don't take a break yet. Just go ahead and start the next video. Keep taking some notes, and let's touch base one more time on calculating ppm based on percentages of salts that you might find in a laboratory.